Okay, um, here we are going, on this video I'm going to cover hypothesis testing with one sample. Since it's mentioning one sample, obviously that means that there can be two samples also. But in this course, we will go over only one sample. What is hypothesis testing, and why do we learn? What's the importance of hypothesis testing? Let's assume sport people who participate in Olympic Games, they usually being checked, right, on steroid. So if they ask the player that did he take steroid, he claimed that not, he didn't. But let's say if somebody is suspecting something, then they can check. Or if let's say some car manufacturer, Toyota, Volkswagen, or any Honda or any other manufacturer, they claim that longevity of their cars is let's say 250,000 miles, so it's only a claim. So you can do hypothesis testing to figure out if you're gonna reject the claim or accept it, which in a language of statistics they don't say accept it, they say fail to reject, which means accept. They use kind of similar to the language of law, not guilty unless it's proven otherwise. Something it's reject, not reject, and fail to reject. We don't use in the language of statistics as accept. Okay. So that's what hypothesis testing is for. What we are going to cover here, we are going to cover introduction to hypothesis testing and hypothesis testing for the mean. In this case, I'm not going to cover for small samples, because just like from the previous case, you learned how to use t-score. Here also you can use same way t-score. It's not a big difference. So all we will do, we cover a large sample, make your life easier. Because whenever, since you are familiar with t-score, you will know all you have to do, just plug t-score instead of z-score, and you know how to work with the table. So I'm just trying to make your life a little bit easier, not to load on you too much. So let's start. Introduction to hypothesis testing. So to test the claim, which means to test the hypothesis, all we have to do, we are going to use the hypothesis, which is going to be null, and the other one is going to be alternative. Where from it's coming and why only two? So you either believe or you don't believe, right? You either reject or you fail to reject. So the one is the case, true case, the other one is complement. Although we don't know which one is a case, which one is a complement. But the bottom line is, between these two, one is a true case, the other one is complement. The same way here, null hypothesis and alternative. If alternative is the true case, null is null is complement. If null case is true, alternative is the complement. Okay. So, and then we are going to, there are also, it obviously can be a case where we are mistaken in our hypothesis test, and because it's statistics, we always leave space for error, obviously. And that's where we are going to explore type 1 and type 2 error and figure out the level of significance. So what we are going to learn in this section, how to determine if it's one tail or two tails, and how to find the p-value. And based on that test, hypothesis test, we can figure out the decision, make the decision, and do interpretation based on results of the statistical test. So, and also we will learn how to write the claim for the statistical test. So what is statistical test by definition? It's a sample statistics. The sample is going to test the claim about value of population parameter. So here is example. An automobile manufacturer advertised that its hybrid car has a mean mileage of 50 miles per gallon. To test this claim, a sample would be taken. If the sample mean differs from this from their claim, let's say they claim that it takes 50 miles per gallon, you are doing testing that claim and it's turned out it's 40 miles per gallon, then you decide that advertisement is wrong and you reject the claim, obviously. Okay. Statistical hypothesis, it's a statement about population parameter. So the main parameter we are going to test here, it's going to be population mean. So like we said, we need a pair of hypotheses. One is going to represent the claim, the other one is going to represent its complement. Nothing new anymore, you already heard this. So, and when one is false, the other one is true. When one is true, the other one is false. It can be either one. All right. Null hypothesis. How do we differentiate null and alternative? How do we recognize in the written form which one is null, which one is alternative? Null hypothesis always is gonna carry equal sign here. See, less equal. Here is equal sign and here is greater equal. Okay? Alternative doesn't have any equal sign. See, greater. There is no equal sign. Less. Not equal and less. So what is interesting? So you can understand. If null hypothesis claim is less equal, complement will be greater, right? If null hypothesis claim equal sign, alternative will be not equal. If null hypothesis claim greater equal, then alternative will be less. So this is gonna be our case for hypothesis testing. Null hypothesis we write down in the format of H0, null, alternative H alpha, or sometimes they just put HI, A. Okay? So if it's given one, the other one we can write down. So let's assume if it's given null hypothesis, this is a syntax, null hypothesis mu is less than k, this is k is a value that claimed, then alternative will be mu is greater than k. Again, null hypothesis always carry equal sign. Next, null hypothesis, if greater equal k, then alternative will be less than k. And as you pay attention, it carries, null hypothesis carries equal sign, alternative does not. And the third case, it's mu is equal claimed value, and alternative will be mu is not equal claimed value. Okay? So, what is very important, we always start testing by accepting that mu is equal claimed value, which means it's not guilty until it's proven otherwise. When you start making friends with somebody, you trust him, right? Unless they give you reason not to trust. Okay, that's how it is. They take the claim as a true, and then we examining and we check it, we test it. If it's not the case, then we reject it and we say no, that's not the case. So let's figure it out. Now, next our question is how to identify what is given in the word problem, null hypothesis or alternative, because either one can be given in the word problem. Let's read it. A school publicized that proportion of its students who are involved in at least one extracurricular activity is 61%. This is what is equal. Important. So that the proportion is 61%. A lot of students get confused. Okay, it's not working again. Okay, well, that's fine. A lot of students get confused with this at least. But it at least has nothing to do with 61%. At least has what to do with the amount of students who are involved in extracurricular activity. In our 61, it's a proportion, not about student. It's about proportion. That therefore is. When we have is, mathematically is represented as a equal sign, correct? So if it's equal sign, then the claim that is given in the word problem, it's going to be what? Of course, null hypothesis, because equal sign is present, 0.61. So what is left on the for the alternative one? Not equal. Proportion is not equal 0.61. What is important, every time when you write down a hypothesis test, you always in parentheses mark down which one is your claim, because claim can be either null hypothesis or alternative. And also it's very important to know which one is claim, because you draw result based on claim. If result is about null hypothesis, then the based on interpretation will be about null hypothesis. If claim is the alternative hypothesis, then interpretation is going to be about alternative. Okay? Write the claim as a mathematical statement, a sentence. Okay, a car dealership announced that the mean time for an oil change is less than 15 minutes. I'll tell you up front, I don't believe it. That would be dream never coming true, 15 minutes oil change. But let's see, it's less than, is there equal sign in this statement? No, there is no equal sign, which means if it would say at least, then equal sign would be present, right? But less than 15 minutes, that means this given is alternative one, not null, because null hypothesis always carries equal sign, correct? Look, it says mu is less than 15, and this is the claim. All right? And null accordingly will be greater equal 15 minutes. Null always going to carry equal sign. Next one, company advertises that mean life of its furnaces is more than 18. Okay, is more than 18. What do you think? Will it be null or alternative? Of course, it's going to be alternative, because it's more than. It doesn't say at least. So let's see. And indeed, more than, because equal sign is missing, so that is going to be the claim. And null is going to be mu less equal 18 years. Okay. Errors. I don't think we have, I placed the errors there because errors are going to be, are very, very confusing. So I don't think I put their errors. Yeah, I didn't put their errors. But one thing you need to know that one way or another, you might have, obviously there some will be case when our test is gonna be wrong, and we will reject when we should fail to reject, or we should fail to reject when we should reject. Okay. So, and based on that, if we do mistakes, there will be types of error generated. So, real quick, I'll go over so you can know how to use the table. So, if null hypothesis is true, given null hypothesis is true, but we did not reject, which means we accept it, right? That means we did correct decision. See that? We did correct decision. Let me see if I can change the color. No, it's not working. Okay, that's fine. But if null hypothesis is false and we did not reject, which means we accepted that false, we generate type 2 error. Correct? It's false and we believed it. That's type 2 error. So we create type 2 error. Next, null hypothesis is true, but we reject that truth. We don't believe it. We create type 1 error. And type 2 error when null hypothesis is rejected, and rejected when it is false. So that's how it's created. It can be true, the claim is true, but we reject. Claim can be false and we fail to reject, which means we accept it. So two types of error can create. Obviously, they can have horrible consequences. In first case, let's go over example for type 1 and type 2 error. So usually USDA limit salmonella contamination for chicken is 20%. Claim is 20%. A meat inspector reports that chicken produced by company exceed USDA limit. So it doesn't believe. The inspector doesn't believe that there are 20% within limit. It says, no, it's more. You perform hypothesis tests to determine whether the meat inspector claim is true. When will type 1 error occur? Remember, let's go back. Type 1 error will occur if the claim is true, which means indeed within 20% contamination, and inspector does not believe, rejecting null hypothesis. So that's great type 1 error. What's going to happen if within 20% contamination, although I believe even 20% is too much, and but inspector doesn't believe it, so it's going to hit the business, right? Chickens are normal chickens, are for the buy and eat, but nobody will buy because because of claim of decision of inspector. But if the claim is wrong, meaning if the truth is it's more than 20% contamination, but inspector failed to reject, meaning did not reject, that means people are going to eat chicken with contamination. So as you can see, type 1 error is generating more dangerous consequences. People will get sick, right and left. We understand? Okay, and here you have this claim. So it's the claim that proportion is 20% less equal, and alternative, I mean, is he's claiming is more than 20%, which means null is less equal 20% or 0.2. So type 1 error, we already talked about it. Type 1 error is rejecting null hypothesis when it's true. So result is, like I said, people will not buy, and there will be business loss. But type 2 error, it's going to bring to sickness of people. So type 2 error, it's much more dangerous than type 1. Okay. Here is written everything I already talked about. So you can put on the post if you are interested, you can read. Level of significance. How much can be level of significance? It's every product has its own level of significance that allowed by FDA. So your maximum allowable probability of making type 1 error. So we denote by alpha. So by letting the level of significance at small amount, at small value, you are saying that you want the probability of rejecting a true null hypothesis to be small. So if we take 5%, the smaller we take, the better it is. That's because we want to be the mistake as less percent, as little percentage as possible, obviously. Okay. So commonly used levels: alpha 10%, 5%, 1%. Type 2 error is a beta, but we are not going to explore. We are going to explore only alpha. So statistical test. Let's see. What we are going to do, we are going to take sample and test the sample statistic. Remember what is the test sample statistic? So if mu is a parameter of population, if mu is a parameter, population parameter, then x bar is a sample statistic. So statistic represent parameter. Okay? All right, let me clean. Oh, it won't clean. Okay, well, here it is. Mu is represented by statistic with x bar. This is we are not going to cover. We are going to cover only mu. Okay? P-value or probability value. P meaning probability. So if the null hypothesis is true that we obtain from this the test statistics, sample statistic, then 1 with the value as extreme or more extreme than 1 determined from the sample data. Let's see. Let's go to example. It's easier, like I said, 1 time to see than 10 times to hear. So first of all, we need to learn, before that we go there, we have to learn what are 3 types of hypothesis test. Left tail, right tail, 2 tails. This is left tail. We call Z critical here. Right tail, this is negative Z critical. This is right tail. It's nothing new. You already know this stuff. And 2 tail. Negative Z critical, positive Z critical. Yep. So let's go. How we are going to identify based on alternative hypothesis. This is alternative hypothesis. If it says alternative hypothesis less than, that means that's a left tail. Here it is. And p-value is the area percentage of the error. If the alternative, it says more than k, then it's a right tail and p-value is the error. If it says equal, not equal, then it's a two-tail test. It's for p-value will be for two-tail, so for each one will be 1/2. Right? Okay. So, a school publicizes the proportion of its students who are involved in at least extra or curricular activity is 61. So if null hypothesis is proportion is 0.61, then alternative will be not equal 0.61, yes? And because the other one alternative is not equal, that means we have two-tail test, correct? Two-tail test. Here it is. If p-value is for both areas, then 1/2 of p for each area. Next, car dealership, we already went through, it's less than. So alternative is less than, that means we have left tail, correct? Because it's less. And here it is. So again, you look at the alternative. So it's more than, alternative is more than, it's going to be right tail. There we go. So p-value will be allowed permitted error. Okay, so now how can we make decision? So alpha is allowable error. FDA allow you, like let's say allows 20% of contamination. P-value is your own error, the one you got it. And you compare p-value to given permittable alpha. If it's within that permitted error, then you are fine. If it's not, then you are screwed up. So what do we have? If p is less than alpha, then you reject. If p-value is greater than alpha, then you fail to reject. Let's see what we are getting here. I'm going to move to example. So, let's see, I want to go to, let's go to example. Here is step by step is telling you what to do. I will cover all this as we find it, as we go to problem. So let's go to problem. So how are we going to use it? Based on p-value, how are we going to test it? So one more time, p-value is less equal alpha, we reject null hypothesis. P-value greater than alpha, then we fail to reject, which means we accept null hypothesis. Let's see. P-value for hypothesis test is 0.02. What is the decision if level of significance is 0.05? What we are getting here? 0.05, it's here, this is alpha. 0.02 is this one, right? So this is what's happening here. Then you reject it because p-value is what? 0.02 is less than, this is your p-value, this is your alpha. Its p-value is less than alpha, so which means you reject null hypothesis because it's falling in the error area. Now, how about alpha is 0.01? If my alpha is 0.01, then p-value is gonna be greater than, right, 0.0237. That means the error is here and the value of p falling into healthy area. Then we do what? We fail to reject null hypothesis. Okay? So how to find that p-value? Alpha is always given, that permittable error. How gonna find the p-value? Very easy. It's practically percentage from the z-score table. For left area, it's gonna be area to the left. For right tail, it's gonna be area to the right. So which means you're gonna deal with 1 minus percentage, correct? Two tail, you are gonna split. I'll tell you about two tail. So find p-value for left tail test with test statistics of z equal negative 2.23. Okay. Z-score negative 2.23. So we need to find this area, p-value. If you open your z-score table, negative 2.23, how much it will be? It's gonna be, I don't have it, I'm not opening because I rely that you already know how to work with it. 0.0129. So it's gonna be somewhere between 2 and 3. 0.0129. So if you compare this value, then compare to alpha 0.05, so you will see that 0.01 is here. This is your alpha 0.01, and 0.0129, this is your p-value 0.0129. So it's out of alpha, it's falling in the permitted area. Yes, so we fail to reject. It's in the healthy area. Here, z-score is two-tailed. Z-score is 2.14. So if z-score is 2.14, so this is positive 2.14, this is negative 2.14. I'm going to show you very easy way. When it's two-tailed and it's give you positive 2.14, these areas are equal. That means this one, if it's positive 2.14, this is negative 2.14. The easiest way to find out probability for z-score is equal negative 2.14. And whatever value you get, you flip the sign and you will get positive. It's going to be same thing. Which is going to be 0. If you check z-score negative 2.114, you should get 0.0162. And you don't have to go, oh, wait a minute. You should get 0.0, hold on, messed up. If you get probability for z-score, I was looking at number, I thought that one is z-score is equal negative 2.14, you should get 0.0324. Okay, that's all it is, because the areas are equal. Its z-score is one is positive, one is negative. So 0.0324. Now compare 0.0324 with 0.05. What is going to happen? It's going to be less than, right? This is 0.05. This is 0.03. So it's falling within this error, and therefore we are going to reject because it's in the error area. We cannot have it. Reject null hypothesis. We always reject, in this case, we work with null hypothesis. So let's solve the z-test for the large sample. To calculate z-score table, it's going to be z-score is equal x bar minus mu over sigma over square root n. It's nothing new. You already know about that. Yes? We call it standardized test statistics. And we always use when n is greater or equal 30. So moving to the problem, word problem. You can read all this. I'm not going to read. This video is not for sitting and reading. I mean, that you will get bored, and otherwise you can think, why are you recording? We can read it. So let's solve the problem. Hypothesis testing using p-values. In auto racing, a pit crew claimed that its mean stop time is less than 13 seconds. What is the claim, null or alternative? That's right, alternative, because it's less than 13. A random section of N32 pit stopped. I'm not writing down because I know all this data will come on, and if I write down, I can't clean. See, it's got frozen, this editing format, so it will create mess. So less than 13 seconds, that's an alternative claim, right? So our claim is alternative one because equal sign is missing there. Random selection of 32 pit stop times, that's an N, 32 pit stop times, has sample mean. That is our sample mean, is our X bar, sample mean. This is our N. This is our null hypothesis, alternative hypothesis, and this is our X bar. And standard deviation S, because it's a sample, standard deviation on 0.19 seconds. So is there enough evidence to support what they want to know? Do we support this claim or we reject this claim? So alpha 0.01. So we need to find, what do we have to do? We need to find p-value and then compare p-value to alpha, right? Just like we were doing before. With the only difference, we don't have z-score to find p-value. Therefore, z-score is a formula that we just learned it. Let's see. It's going to show up. Less equal, it's 0.01. It's everything is given. Here is the formula. Z-score is equal. Once we calculate z-score, nothing can stop us. We can, by this z-score, find out p-value and then compare to alpha and make decision. So X bar minus 12.9, so X bar is 0.9. Mu is 13 because we are testing 13, right? That's a claim. And 0.19, that's your S or sigma. That's your standard deviation. And over 32, square root 32, that's your N. Okay? All right. Okay, so it's since sample size is larger, so we can put the population. So this would be population sigma. So you do this calculation. What's the order? First, you have to do whatever in denominator, divide 0.19 by the square root 32, and then subtract whatever on the top, and then divide top, divide by bottom. And you should get approximately negative 2.98. Why we take here approximation? Because z-score has only 2 decimal notations after whole point, right? So 2.98. So if you look into z-score equal negative 2.98, you will get probability is going to be 0.0014. 0.0014. And let's compare 0.0014. If our, let's say, if this is our 0.01, yes, alpha probability, the p-value is going to be much, much less, correct? With much, much less, that means it's falling in the area of error. Therefore, if it's falling in the area of error, we always reject null hypothesis. But because our claim is alternative, so if we reject null, that means we fail to reject alternative, right? We accept alternative one, correct? Okay, so, and we draw the conclusion. At 1% significance level, you have sufficient evidence to support the claim, this claim, because this is our claim, that the mean pit stop time is less than 13 seconds. How are we doing? I hope you are doing good. If not, you can always contact me, you know that. Let me see. Let's solve this one. The National Institute of Diabetes and Digestive and Kidney Disease report that average cost of bariatric loss weight surgery is $22,500. It's crazy if somebody want to go to surgery for losing weight. You think this information is incorrect. You randomly select 30 that you're in bariatric surgery patient and find that their surgeries is 545 with standard deviation 3015. So what's the decision you can do? Is there enough evidence to support the claim at alpha equals 0.05? All right. It claimed that it's not 22,500. That means alternative will be E is equal to 22,500. Alpha is 0.05. So again, we need to find z-score where X bar is 21,545. Mu is claim is 22,500. Sigma is 3,015, and the sample size is 30. So after we make calculation, we get negative 1.73. For z-score is equal negative 1.73. This is our z-score table. Negative 1, this is negative 1.7, 0.03. Let's say this one, 0.03. So you will get here how much? You will get here 0.0836. Why do we get 0.0836? Because here we have two tail. Remember, we have two tail. The one we find it would be for left tail, so which would be 0.0418. And to find for two tails, you have to multiply by 2, and you will get 0.0836. Okay. So we take 0.0836 and it's greater than 0.05. That means we fail to reject null hypothesis. And because we fail to reject, that means we reject alternative one, and that is the claim. So with 5% significance level, there is not enough evidence to support the claim. So because we rejected, we support not enough evidence to support the claim that mean cost of bariatric surgery is different from 22,500. How are we doing? Hopefully you are doing well. It's not difficult, it can be just confusing. It will be easier when you start doing your homework and it will fill in the pieces, let's say. Okay, going based on rejection. I don't think I covered it, so I'm going to leave it right there. But with rejection region, all you're gonna do instead of the only difference is you're gonna compare z-scores. There you were comparing alpha and p-value. Here you're comparing z-scores. How you gonna get z-score? Okay, once I started, let me get going, finish this one also. I don't remember. I don't think you have in homework, but whoever is interested, you can listen. So here we are going to compare z-scores. Z-critical, that is the matching z-score to alpha, and then our z-score, that z-score for our p-value. So let's see. It says find the critical value and the rejection region for two-tail test with alpha 0.05. If for two tails 0.05, that means for one tail will be 0.025, right? Half of it. So if we find the z-score for 0.025 for alpha, always z-score for alpha, it's going to be our z-critical, which you will get negative 1.96. Once you find negative 1.96, you take the same sign, flip on the plus, and you get for positive 1. Otherwise, you don't need to do anything. If you get negative z critical, negative 2.175, then for positive z critical will be positive 2.175. All right? Here we go. So for the z critical for alpha equals 0.05 is equal plus minus 1.96. Now we are going to compare this value to this value instead of alpha. There, previously we were comparing percentages. Alpha was percentage, p-value was percentage. Now we are going to compare with the z-score of these percentages backwards. Okay. So those are steps. So left tail, right tail, we already know. Two tails, we're already familiar. So if our z-score, that is a z-score of p-value, is falling within, it's less than this z-critical, then we reject. If it's greater for right tail, then we reject here. And if it's falling in, again, the rejection area, in error area, then we reject. So let's solve examples. That will be the best. Here is the problem. So here we have alpha. So instead of calculating p-value and comparing to alpha, now we are taking z-score for alpha and z-score for p-value. Let's see how we are going to do it. Employees at the construction and mining company claim that mean salary of the company's mechanical engineers is less than the one of its competitors, which is 68. So see, you have less and you have is. Remember one thing, if you if the language giving you confusion, then always take the sign, the one that is right next to the value, which is, which means it's going to be the two-tailed test. A random sample, this is n of 30 of the company mechanical engineers, says that the mean salary, this is x bar, with the standard deviation 5,500. Sigma. Alpha 0.05. Claim, find the employee's claim. This is mu, I'm sorry. Okay. No, mu is, we have already mu. X bar. Okay. Let's see. Claim is less than 68,000. Well, see, I got confused myself here also. Let's read one more time. The mean salary of company's mechanical engineer is less than the one A, which means they say that the neighbors' competitors have 68,000, and their company, the company of the claimer says we get less than neighbor company. Okay, so since English is your mother tongue, I'm sure you understand better. So one more time, that mean salary of company's mechanical engineers is less than that of one of its competitors. So it's less, which is 68,000. So less than 68,000. It's interesting. The way they put it, it's, they could say the competitors get 68,000 and they claim that their money is less than competitors, and would be clear, so it's less than 68. Okay. Moving on. Alpha 0.05, rejection region. So here, like I said, we are not dealing with p-value, alpha value, but alpha given. We are going to get the z-score for alpha. If alpha 0.05 and it's a left tail, so we don't need to split alpha. So on the z-score table, you have to find 5% and it will match z-score negative 1.645. Then we need to find our own z-score through p-value. Z-score is equal x bar minus mu sigma over square root of n. Since our z-score we already found out, you don't want to go through p-value. You take this z-score and compare to this one. So negative 1.645 and negative 1.1. So between negative 1.645 and negative 1.1, 1.1 is, negative 1.1 is always greater than 1, negative 1.645, right? Therefore, it's going to fall in the healthy area, which means what? If it's falling in the healthy area, what do? You fail to reject null hypothesis. If you, but because your claim is alternative, that means if you fail to reject null, that means you reject alternative. Correct? So, at 5% significance level, there is not sufficient evidence to support, which means we are rejecting, to support the claim that mean salary is less than $68,000. Okay? This one I think is longer story. No, let's solve this one also. U.S. Department of Agriculture claimed that mean cost of raising child from birth to age 2 by a husband-wife family is $13,120. This is for sure, is. A random sample of 500 children, that's a sample size, has mean cost, X bar, 12,925 with standard deviation. Sigma is 1,745. Alpha 0.1, we need to figure out if we are going reject or fail to reject and figure out if there is enough evidence to reject the claim. So, if claim is 13,120, then alternative will be not equal, which means we have two tail. Alpha is 0.1. So what's going to be rejection region based on z-score? Z-score for this alpha, 0.1. Obviously, remember what you're going to do. 0.1 in the body, because it's percentage. And you go find the z-score, which is going to be negative 1.6. And it's going to be falling here 0.04, 0.05. And will be 0.045. And here it is. Plus minus 1.645 because we have two tail. Okay, next we are getting test statistics, z-score. Once we get z-score negative 2.5 and compare to this one, negative 2.5 is less than 1.645, which means what we're going to do? We're going to reject null hypothesis. If we reject null hypothesis, that means we failed. Well, actually, our claim is null hypothesis, so we don't go to alternative anymore. If we reject null hypothesis, then we can say with 10% significance level, we have enough evidence to reject, not to support, to reject the claim for cost about the main cost of raising a child from birth to age 2 by husband-wife family in the U.S. is $13,120. That's all. That's all. We finished 7.2. Thank you for watching. Thank you for listening. Contact me if you have questions.